Okay. Good morning, all of you. This is Srikanth from Mechanical Department. The subject name is Finite Element Method. So this is one of the main important subject in your present first semester for final first semester. So all of you don't share any type of presentation. At the same time, mute your audio. At the same time, switch off your video also. Okay. The subject name is Finite Element Method. Okay. So in this is the syllabus of finite element methods. Okay, unit 1, unit 2, 3, 4, 5, 6, overall 6 units, total 6 units. Okay, so at the same time, the unit number 1, today's topic is introduction of finite element methods. Today's topic is introduction of finite element methods. All of you please listen. Today onwards, I'm discussing in this but first class. So introduction of finite element methods. What is the main purpose of finite element methods? What is the definition of finite element methods? At the same time, some applications, advantage and disadvantages of finite element methods. So listen carefully. This is the syllabus of finite element methods in all 6 units. Okay, at the same time, course outcomes. In this particular finite element method, it will be including into some course outcomes. So first one, in the course outcomes, the first one, understanding the concept of behind variational methods and weighted residual methods of finite element methods. It will be including into some differential equations. In this particular unit 1, it will be including into some differential equations. Already I'm discussing in the CFD lab. Also we are discussing in differential equations. Okay, in this first unit it will be including into the differential equations by using weighted residual methods. And the next one, 4 point, in these particular course outcomes, it will be including into the course code at the same time subject code is C403. So okay, the code of the subject is C403 in the unit number 1 course outcome, unit number 2 course outcome, unit number 3 course outcome. So in the unit number 1 it will be including into, so listen carefully, course outcomes is very important in any type of subject also. So briefly discussing course outcomes. In the course outcome means what is the output of the first unit, what is the output of the second unit. Okay, so in the unit number 1, what is the output? In this particular unit number 1, it will be including into the understanding the concept of variation methods and weighted residual methods in the finite element method. Okay, so it will be including into 99%, it will be including into differential equations. So all of you, I'm discussing in the computational fluid dynamics lab, it will be including into differential equations also. Okay, so in the unit number 1, it will be including into differential equations. 90% it will be including into differential equations. Okay, so unit number 2, concept understanding the concept of discretization procedure and global coordinates. So this is the unit number 2 is very easy. I'm explaining. So I'm explaining various methods of by using the unit number 2, and then unit number 3, develop the element characteristics by using generation of global stiffness equations. Okay, it will be including into analysis of trusses and analysis of beams. Already you know that analysis of beam, analysis of trusses, that will be including into strength of materials. So the finite element method is the third stage of your mechanical department. Sorry, in our mechanical department, this is the third stage. The stage number 1 is engineering mechanics. So stage number 1 is engineering mechanics, and stage number 2 is strength of materials, and stage number 3 is finite element methods. So after first year and second year, and then it will be including into start the final year. So step number 1, engineering mechanics is the first year subject. Strength of materials is the second year subject. It will be follows the, it will be including in some same syllabus, it will be including in some related syllabus, it will be including it that finite element method. Okay, so this is the process for finite element methods. And then program outcomes. These program outcomes are same as all subjects. In these program outcomes, it will be including into total total college. Okay, and then course outcome relationship matrix. That means what is the problematic, what is the theoretical, what is the something, and it means the subject code PO means 3. it will be used to highly problematic. So at the same time, course outcome 2 also it will be including into problematic. So the total units, the unit number 1 and unit number 6, total units must and should be, the problematic only. 95% it will be including into problematic. Okay. So let's discuss the subject, the finite element methods. Just introduction of finite element method. Okay, introduction of finite element method. So in these first of all, we discuss the introduction of finite element methods. Means it will be used to what is the meaning of finite, what is the meaning of element, finite and element. Okay, so in this particular finite and element means it will be used to one of the main example. So listen carefully. I'm taking one wall. By using in these introduction of finite element methods, we are taking one wall. Okay, in this particular wall it will be including into number of bricks. Okay, so I'm taking one type of wall. Okay, horizontal or vertical, any type of wall. Okay, in that particular wall it will be including into number of bricks. Okay, so number of bricks will be including into the particular wall. It's clear. So I have some calculations in the particular wall. So in that particular wall it will be including into some number of bricks. So example of finite element methods, for example, we are taking, so example of finite element method. After that I'm discussing definition. Okay, so first of all, this is the wall. For example, this is the wall. So it will be including into various types of bricks. All of you please listen. This is the wall. Okay, so in this particular wall it will be including into various types of bricks. For example, brick number 1, brick number 2, brick number 3, 4, 5, 6, 7, 8, 9. So in this particular wall it will be including into various types of bricks. So nine bricks will be including into the wall. Okay, and then what is the meaning of node, what is the meaning of element? So for example, I'm taking element is one brick. Okay, so element is one brick. Okay, node is every brick have a 4 or 8 points. It means sorry, for example, brick is a cubic. Okay, brick is also called as cube. In this particular cube it will be including into 8 corner points. Okay, so at the same time, in see my cursor. So this is the point, this is the point. In the dark mark is a node. This is also second node. So each brick have a 4 nodal points. 1, 2, 3, 4. Once again, this is the wall. It will be including into number of bricks. So each, how many bricks it will be including into the particular wall? 9 bricks. Okay, so in that particular wall it will be including into 9 bricks. So this is the first one, brick number 1. So I'm also called as brick is equal to element. In the brick is also called as, in the finite element method it is also called as element. Brick is also called as element. Okay, it's clear. Next one, in the particular brick it will be including into various types of nodal points. So this is the brick number 1, node 1, node 2, node 3, node 4. At the same time, second brick, 2, 3, 4, 5. Okay, so all of you please listen. In that particular wall it will be including into number of bricks. At the same time, number of elements. So in that particular finite means, whole bricks will be assembled together in the particular wall. That is the finite. It will be including into some bricks. The bricks is also called as element. So we are discussing, we are solved some calculations. So for example, this is the wall. Okay, this is the wall. It will be including into 9 bricks. This is the wall. It will be including into 9 bricks. Okay, this is the first end, this is the second end, for example, starting end and ending end. For example, in this particular brick I am applying some tensile load into the end of the brick. Okay, Once again, this is the wall. It will be including into 9 bricks or 9 elements. So each element should be have a 4 nodal points. 1, 2, 3, 4. Okay. Each brick have a 4 nodal points, and then total bricks of the particular wall is equal to 9. So after that, this is the end point. This is the end point. So in this particular position, I am applying some tensile load. So tensile load means, what is the meaning of tensile load? So tensile load will be applying in each brick. Okay. So at the same time, definitely after applying in tensile load in the particular wall, in the particular brick also, it will be moves some displacement. Okay, it will be more some elongation. So after that, definitely it will be changes the some displacement. For example, I am taking brick number 1. Okay, for example, I am taking brick number 1. Brick is also called as domain. Okay, in the finite element methods, it will be named as brick is also called as element, also called as domain. Okay, in this particular brick, only one, I am taking only one brick. I am taking only first brick. In this first brick, I am applying in tensile load. Okay, tensile load I am applying in pushing, means tensile load will be applied into the first brick. So after applying in the load in the first brick, definitely the length of the brick, for example, I am taking length of the brick is equal to 5 centimeters, for example. Okay, before you are applying in load, the length of the brick in the brick number 1 to 2, between the gap is 5 centimeters. So after that, the load will be applied. Definitely after will be low. After that, the load will be applied. The load is tensile load. At the time, the 5 centimeters will be increases. Okay, so 5 centimeters to 7 centimeters. After load will be applied. At that time, how much stress will be induced in the brick number 1? How much strain? How much displacement? How much support reactions? These are the 4 things we are find out. Okay, in that particular finite element method, brick number 1 and brick number 2, each and every brick equal dimensions. So the brick number 1 and brick number 2, at the same time brick number 9 also equal dimensions. That means size, width, height, weight same. Each and every dimension is equal. Okay, each and every dimension of the brick is equal. So we are find out only one brick. We are find out the only one brick. So we are find out only one brick. That means what type of things we are find out after load will be applied. After load will be applied, Lokendra Kumar, don't share any type of presentation. Lokendra Kumar. Okay, listen carefully. At the same time, I'm discussing. This is the wall in your screen, presenting in the screen. This is the wall. In this particular wall, it will be including into 9 bricks. So each and every brick same dimensions. So sorry, equal dimensions. That means length, width, height also same. At that time, I'm taking only one brick to find out the stresses, to find out the strain, to find out the displacement, to find out the support reactions also. So these are the 4 things we are find out the unit number 2, unit number 3, unit number 4 also. But the name of the unit will be different. Okay. So in this particular subject, we are find out each and every brick value. Okay. For example, this is the wall. This is the wall. It will be including into 9 bricks. So 9 bricks is equal to equal dimensions. So at that time, with help of these type of finite element methods, by using these type of finite element method, we are choosing only one brick to find out the stresses, to find out the displacements, to find out the strains also, to find out the strains in brick number 1 is equal to brick number 2, 3, 4, 5, 6, 7, 8, 9. So we are find out only one brick, the same values will be taken into the remaining bricks. Okay, so this is the finite element methods. So first of all, we are discussing the definition of finite element method. So listen carefully. Okay, in this finite element method is a numerical method. It will be including into some problematic. That means in this finite element method is a numerical method in which then unknown function of the problem, for example, already I am saying about this particular process. Okay, now it's okay. Pavan Varma.
Yes, sir. Okay, sir.
Okay. The
Yes, sir.
definition of finite element method. The definition of finite element method. Listen carefully. In this finite element method, it will be including into some numerical problems or numerical method also. So this is the numerical method. Already I am saying about the starting 2 or 3 minutes in that particular class. This is the in this particular finite element method is totally problematic subject. Okay, once again, in this finite element method is totally problematic subject. Okay, so each and every unit must and should 99% the problematic will be including into the each unit. Already I am saying about this finite element method, the stage number 3. Stage number 1, engineering mechanics. Stage number 2, strength of materials. Stage number 3, finite element methods. Okay, it's clear. So that this is the stage number 3. It will be including into some numerical method also. Once again, the definition of the finite element method is, in this finite element method is the numerical method, when which then unknown function of the problem. For example, I am already saying about this type of problem. This is the example of finite element method. For example, already with help of this type of wall, it will be including into 9 bricks. It's clear. So in that particular bricks, I am applying in tensile load at the end of the point. The tensile load will be applied. Okay, at that time, to find out the each and every brick values, each and every brick should be things, what type of things we are needed. Each brick, what is the stresses, what is the displacement, what is the strain, what is the support reactions. So we are find out each and every brick. These are the things we are calculate when after load will be applied. Okay, so after load will be applied, these are the things we are calculate. Okay, but by using this type of finite element methods to unknown functions, so unknown brick values also find out with help of one domain. So for example, we are calculate only one brick. We are calculate the only first brick with help of nodal points. Okay, at that time, each brick is equal to each brick is equal to equal dimensions. At the time, to find out the brick number 1 value, we are what type of things we needed. The brick number 1, strain, displacement, stresses, and support reactions. These are the 4 things we are find out the brick number 1. At the same time, brick number 2 values also same. Why? Because the equal dimensions in the all bricks. Okay. So in the unknown function of the problem, for example, unknown function of the problem, that is the domain. Already I am saying about domain. What is the meaning of domain? Domain means brick. Okay, domain means brick. Once again, in this particular definition, it will be including into domain. What is the meaning of domain? Domain means brick. Okay, so brick is also called as in the finite element method element. Domain means brick. Okay, it's clear. The brick is also called as in the finite element method element. Okay, how many elements in the particular wall? 9 elements. How many nodal points? What is the meaning of nodal points? Each element should be have a 4 nodal points. So 9 into 4, 32 nodal points will be 32 nodal points will be including into this particular wall. Okay, so the domain means the object of like bar. So domain means domain means an object of like bar. Bar means, for example, in this particular finite element method, it will be including into two
సార్
dimensional
పీపీటీ
only.
అయిపోయింది సార్.
Okay, okay. 1 second present చేస్తాను, వెయిట్ చేయండి. ఓకే దివక్,
ఎస్ సార్, ఎస్ సార్,
present.
వస్తుంది వస్తుంది సార్.
Okay, okay. Okay, at the same time, in these particular finite element methods, we have a various type of units. The unit number 2 is analysis of bar. Unit number 3 is analysis of trusses and beams. So all of you please listen. The unit number 1, it will be including into differential equations by using weighted residual method, by using variational methods. Okay, the unit number 1 only. Unit number 1, it will be including into 90% of the differential equations. Okay, unit number 2. So in this particular domain means an object like bar. That means analysis of bar. Analysis of bar means it is a only one dimensional. Analysis of bar means either x-axis or y-axis or z-axis. And then beam. In this particular beam, it will be including into two dimensional. X-axis at the same time y-axis also. Okay. So trusses. What is the meaning of trusses? This is also same. Two dimensional. X-axis it will be including into the trusses. At the same time y-axis also. So in this particular domain means domain is an element. Okay. So bar is one dimensional, beam is two dimensional, trusses also two dimensional. So once again, in this finite element method is a numerical method. Okay, in this finite element method is a numerical method in which unknown function of the problem. So we are find out the unknown function of the problem. What type of unknown function we are find out? What type of unknown things into the particular problem we are find out? So what is the meaning of unknown things? To find out the trusses, to find out the strain, to find out the displacement, to find out the reactions. So these are the four things is the unknown function. In this particular definition, it will be including into the unknown function. What is the meaning of unknown function? Already I am saying about, I am taking one element, and that after applying in the load, we are find out stresses, displacement, strain, at the same time support reactions also. These are the four things we are find out. That is the unknown function. Okay, with help of domain, that the in this particular domain is one dimensional, that is bar element. That is the unit number 2 also. One dimensional, that is bar. One dimensional means either x-axis or y-axis or z-axis. Only one axis will be including into the bar only. Okay. Next one, beam. What is the meaning of beam? Already we know that the strength of materials. Okay. In this particular beam, it will be including into two dimensional, x-axis at the same time y-axis also. Okay, and then trusses, it is also including into two dimensional. Okay, so it is approximated by piecewise defined function. What is the meaning of piecewise? Once again, I am taking one of the example. This is the brick. Already we know that the definition, it is approximated by piecewise. So listen carefully. It is approximated by piecewise. What is the meaning of piecewise means? For example, this is the brick. It will be, sorry, this is the wall. In this particular slide, it will be including into total wall, whole wall of the house. Okay, one wall of the house. In this particular wall, it will be including into how many elements? 9 elements. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this particular definition, it is approximated by piecewise defined function. So for example, this is the complex region. Okay, this is the complex region. Okay, in this particular complex region, we are solving piecewise functions or piecewise bricks. So for example, we are taking in this particular wall, it will be including into 9 bricks. So total 9 brick values, it will be the total 9 bricks values. That means stresses, strain, displacement, at the same time support reactions. So each and every brick, find out the individually, it is very tough. Okay, at the same time in this wall, we are find out each and every brick value, we are find outing very tough. At that time, in this particular wall, we are dividing into the piecewise. That means we are dividing into the particular wall. For example, there is a wall, it will be including into 9 bricks. At that time, we are find out brick number 1 first. What is the stress? What is the strain? What is the displacement? What is the reactions? So, and then after completing brick number 1, we are forwarding to brick number 2 to find out the stress, strain, displacement. So same. Okay, each and every brick, same process. And after finally, we are find out the divide. For example, once again, it is approximated by piecewise defined function. Piecewise defined function to find out the individual. Okay, the whole wall brick values, the whole wall stresses, strain, displacement, and support reactions we are find out. So, but there is a complex reason. At the time, we are dividing into the smaller elements. That means smaller parts. Part number 1, part number 2. For example, the complex structure will be divided into easiest structure. Okay, so once again, it is approximated by piecewise defined function. That is the complex region. Okay, that means the domain is divided into smaller elements. That is the main point in the particular definition. Domain is divided into smaller elements. What is the meaning of domain? Domain is a elements. So once again, for example, this is the example of finite element method. It will be including into various type of elements. How many elements? 9 elements. So element is also called as domain. So at that time, we are starting the problem, the step number 1, dividing of each element. So 9 elements. So dividing element number 1 and element number 2 and element number 3. So that is the definition. It will be including into domain is divided into smaller elements. This is the point is very important. Domain is divided into smaller elements, and then the each smaller element is solved individually. Listen carefully. For example, this is the wall. It will be including into various type of domains. Domain is also called as brick. Brick is also called as element. So in this particular in this particular wall, it will be including into 9 domains, 9 bricks, 9 elements. So at that time, this is the complex region, the complex structure also. Why? Because so it will be including into various type of bricks. So at that time, we are find out, we are dividing into the domain is divided into smaller elements. Okay, divided into smaller elements, and then each smaller element, for example, each smaller element or each brick. Okay, each smaller element, at the same time each brick. Okay, so each brick solve individually. Listen carefully. Each smaller element solve individually. So solve individually and finally assemble the all elements of the process. It is also called as finite element methods. For example, just listen carefully. ఒక 2 minutes తెలుగులో చెప్తామమ్మా పర్ఫెక్ట్ గా. ఏదైనా ఒక వాల్ తీసుకుంటే, ఫైనైట్ ఎలిమెంట్ మెథడ్ అంటే ఏంటంటే, ఏదైనా ఒక వాల్ తీసుకుంటే, హౌస్ కు ఉన్న వాల్ తీసుకుంటే, ఆ వాల్ లో డెఫినెట్ గా నెంబర్ ఆఫ్ బ్రిక్స్ ఉంటాయి. Okay, for example, this is the in your present please see your desktop example of finite element method. This is the wall. Okay, in this particular structure is the wall. In the particular structure, it will be including into how many bricks? Brick is also called as element in the finite element methods, also called as domain. Okay, so ఈ బ్రిక్ లో ఈ వాల్ లో మొత్తం 9 బ్రిక్స్ ఉన్నాయి. ఈ 9 బ్రిక్స్ కి ఆ బ్రిక్స్ ని మనం ఫైనైట్ ఎలిమెంట్ మెథడ్ లో ఏమంటున్నాం అంటే ఎలిమెంట్ అంటున్నాం. అట్ ది సేమ్ టైం అనదర్ వర్డ్ ఆల్సో కాల్డ్ యాజ్ డొమైన్. సో 9 బ్రిక్స్ ని ఒకేసారి క్యాలిక్యులేట్ చేయడం జరగదు. సో ఆ 9 బ్రిక్స్ ఒకేసారి క్యాలిక్యులేట్ చేస్తే అది కాంప్లెక్స్ రీజియన్ ఆర్ కాంప్లెక్స్ స్ట్రక్చర్ అవుతుంది. అప్రాక్సిమేట్ గా కూడా వాల్యూస్ రావు, అప్పుడు డిఫికల్ట్, వెరీ డిఫికల్ట్. సో ఎట్ ద టైమ్ ఈచ్ బ్రిక్ ఈజ్ ఈక్వల్ టు ఈక్వల్ డైమెన్షన్స్. ఇట్స్ క్లియర్. ప్రతి బ్రిక్ కూడా సేమ్ డైమెన్షన్స్, లెంత్, వెయిట్, హైట్ ఏదైనా కావచ్చు, సేమ్ డైమెన్షన్స్. సో ఎట్ ద టైమ్ we are dividing into the domain is divided into the smaller elements. So in the particular domain is divided into the smaller elements. Okay, so we are find out brick number 1 first of all to separate the whole structure. The wall లో నుంచి ఒక brick ని separate చేసేయండి. brick number 1 తీసుకున్నాం, only one brick. This is the only one brick. With help of load, with help of Young's modulus value, with help of area of the particular brick, to find out the stress value, to find out the strain value, to find out the displacement value. So and then second one, and then third one, and then fourth one. ఒక్కొక్క బ్రిక్ ని ఒక్కొక్కసారిగా మనం స్ట్రెస్, స్ట్రెయిన్, డిస్ప్లేస్మెంట్, సపోర్ట్ రియాక్షన్స్ సపరేట్ గా కనుక్కోవాలి, find out చేయాలి. సో the definition is domain is divided into smaller elements. Okay, the whole structure, the whole wall will be divided into smaller region or smaller structure. Okay, and then each smaller element, that means each smaller brick solve individually. Listen carefully. Solve individually. ఒక్కొక్క బ్రిక్ ని ఒక్కొక్కసారిగా మనం ఒక్కొక్క వాల్యూస్ ని ఫైండ్ అవుట్ చేయాలి బై యూజింగ్ ఆఫ్ లోడ్, బై యూజింగ్ ఆఫ్ క్రాస్ సెక్షనల్ ఏరియా ఆఫ్ ద బ్రిక్ ఆల్సో. ఓకే, ఈచ్ బ్రిక్ ని ఒక్కొక్కసారిగా ఇండివిజువల్లీ టు సాల్వ్ ద ఇండివిజువల్లీ. దట్ మీన్స్ వాట్ టైప్ ఆఫ్ థింగ్స్ వీఆర్ సాల్వింగ్? స్ట్రెస్సెస్ ఫైండ్ అవుట్ చేయాలి, స్ట్రెయిన్ ఫైండ్ అవుట్ చేయాలి, డిస్ప్లేస్మెంట్ ఫైండ్ అవుట్ చేయాలి, సపోర్ట్ రియాక్షన్స్ ఫైండ్ అవుట్ చేయాలి, ఈచ్ బ్రిక్ వాల్యూ. అండ్ ఫైనల్లీ to find out the 9 bricks individually, and then finally to assemble the all elements. To assemble the all elements, ఒక్కొక్క బ్రిక్ ని ఫైండ్ అవుట్ చేసుకుంటూ వచ్చి 9 బ్రిక్స్ ని విడివిడిగా ఫైండ్ అవుట్ చేసుకుంటూ వచ్చి అండ్ finally assemble the all elements. So in this process also called as finite element method. దాన్ని ఇంకో నేమ్ ఏమంటారంటే stiffness matrix. Okay, so this is the definition of finite element method. Listen carefully once again, all of you. Anyone respond? It's clear or not? The definition of the finite element method, it's clear or not? Anyone respond?
Yes sir.
Yes sir, clear
Okay.
sir.
Okay, next one. So this is the example. Next one, the purpose of finite element method. Okay, next one, the purpose of finite element method. So listen carefully. In this finite element method, including in various common departments. So the finite element methods not only mechanical, it will be including into various type of departments also, various type of branches also. So in this finite element method, including in common for various departments like mechanical, okay, it's clear, civil department, aeronautical department, at the same time automobile department also. Okay, at the same time metallurgy department also. So these are the departments it will be including into the finite element methods. It is a common subject. Okay, we are mechanical, okay, it's clear, but civil department, aeronautical department, automobile department, metallurgical department, mechatronics department, it is a common subject. Okay, it's clear. Next one, in this finite element method uses two complex problems can divided into differential equations. For example, in this finite element method, to solve the complex problems, any type of complex structure, okay, any type of problem to solve by using differential equations, to solve by using these type of finite element methods. Okay, ఏదైనా కానీ ఎనీ టైప్ ఆఫ్ కాంప్లెక్స్ స్ట్రక్చర్ అవ్వచ్చు. ఫర్ ఎగ్జాంపుల్ ఐఎమ్ టేకింగ్ వాల్. Okay, only one wall. For example, I am taking whole house. Okay, how many bricks will be including into the whole house? So each house should be have any, for example, 10 or 20 type of walls. So each wall should be have, it will be including into the 1000, for example, 100 bricks. Okay, so total house, the bricks is equal to, for example, 2000 or 3000. Okay, so any type of complex structure or any type of complex body or any type of difficult problem also to solve by using finite element methods. Okay, next one. In this finite element method uses to solve the various type of problems. By using these type of finite element methods, it will be including in various type of dimensions also. That is one dimensional. Already I am discussing one dimensional. What is the meaning of one dimensional? Bar. Okay, in the definition of finite element methods, it will be including into the bar. One dimensional means bar, two dimensional means trusses and, okay, trusses and beams, and three dimensional means cube. Okay, in your finite element methods, we have only two dimensional and one dimensional. The three dimensional element will be including into the master's technology only. Okay, in that particular finite element methods, we are discussing only finite element method of one dimensional and finite element method of two dimensional only. In the three dimensional, it will be including into master's technology. Any branch we have taken after BTech, after graduation, we are taking post graduation, that means MTech. Any type of branch we are taking, definitely it will be including into the finite element methods, advanced finite element methods. బీటెక్ తర్వాత ఎంటెక్ ఏ బ్రాంచ్కి వెళ్ళినా, ఏ స్పెషలైజేషన్కి వెళ్ళినా డెఫినెట్ గా ఫైనైట్ ఎలిమెంట్ మెథడ్ అనే సబ్జెక్ట్ ఉంటుంది. అది కూడా అడ్వాన్స్డ్ గా ఉంటుంది. 3 dimensional and 6 dimensional are also including into the master's technology, but we have only 1 dimensional and 2 dimensional only. Okay, and then the FEM is covered various type of analysis, that is stresses, thermal stresses and static stresses, and stress analysis and thermal analysis and strain analysis also. So with help of finite element method, we are solving various type of analysis. That means stresses analysis, strain analysis, thermal analysis also. Okay, and then with help of finite element methods, converts the partial differential equations into the algebraic equation. Already we have taken into the particular differential equations in the computational fluid dynamics lab. Okay, so with help of these finite element methods, it will be converts the partial differential equations into the algebraic differential equations with help of polynomial equation. What is the meaning of polynomial equation? I am taking any type of example. Y is equal to a1 plus a2 of x plus a3 of x square and so on. So this is the equation is also called as polynomial equation. With help of this type of polynomial equation, we are find out the differential equation. Okay, this is the main purpose of finite element methods. In this finite element method, the purpose, any type of dimension we are find out. That is the one dimensional we are find out, two dimensional we are find out, three dimensional and six dimensional also. Okay, any type of complex structure we are find out. We are find out any type of complex structure by using finite element methods. Okay, it is also common branch of mechanical, civil, aeronautical, mechatronics and automobile also. Next one. For example, in this finite element method, it will be including into some applications. Okay, in this finite element method, it will be including into some applications. What is the applications? For example, mechanical applications, aerospace, civil, automotive, engineering. In these particular common finite element analysis or common finite element method applications are mechanical applications, aerospace applications, civil, automotive, engineering, and then structural applications and stress analysis. In this stress analysis, it will be including into static and dynamic analysis, linear and non-linear flow analysis, and then fluid flow, heat transfer, electromagnetic fields, soil mechanics, tectonics and biomechanics. So mainly in this finite element method, what is the main example? That is bridges. without finite element method subject, we are does not construct the bridges. Any type of bridge, it is a small or big also. Okay. Okay, and then next one, the next step of the finite element analysis or finite element method, it will be divided into two types. Okay, what is complex object, another one is simple analysis. Already in this particular process, already I am saying about only definition. So in the particular finite element method or finite element analysis, okay, uh, that is a complex object, any type of complex object or any type of complex structure. With help of finite element method, we convert the simple analysis. Already we know that in the definition of finite element method, divided into smaller elements. The complex region will be converted to smaller region. That means, okay, we are taking, that means that is also called as discretization. Discretization means any type of complex structure or any type of complex region, we are dividing into the smaller analysis or smaller structure. ఏదైతే టఫ్ గా ఉన్న స్ట్రక్చర్ ఏదైతే ఉందో, ఏదైతే క్రిటికల్ గా ఉన్న ప్రాబ్లం ఏదైతే ఉందో, ఏదైతే క్రిటికల్ గా ఉన్న క్యూబ్ ఏదైతే ఉందో, ఎనీ టైప్ ఆఫ్ ప్రాబ్లం, డెఫినెట్ గా క్రిటికల్ గా ఉన్న ప్రాబ్లం ని విత్ హెల్ప్ ఆఫ్ ఫైనైట్ ఎలిమెంట్ మెథడ్, విత్ హెల్ప్ ఆఫ్ డిస్క్రిటైజేషన్ ప్రాసెస్ ద్వారా మనం సింపుల్ గా అనాలిసిస్ చేయొచ్చు. It's clear. Okay, that is the meaning of discretization. Once again, the discretization means, so definition 99% the unit number 1 is the shortest question. Okay, what is the meaning of discretization? Any type of model body or any type of complex structure or any type of complex region. Okay, the discretization means any type of complex structure, any type of complex body or any type of complex region also, dividing into the equivalent system. Okay, the model body means, what is the meaning of model body? Complex region or complex structure. Okay, the complex structure is dividing into an equal systems. Already we know that one of the example of finite element method. Okay, the discretization by using one example of finite element method, we are saying about the definition of discretization also. Okay, in this discretization process, this is the model body, for example. In this discretization process, okay, it will be including into the also discretization definition. In this discretization means, definition of discretization means, for example, this is the one body, whole body, this is the one wall, also called as whole body. In this particular body is divided into smaller elements. That means the element is divided into individually. Okay, so in this is a complex structure or model body is divided into smaller elements. Once again, we are forward the discretization process. Okay, once again, the model body, also called as complex structure, is divided into a equivalent system. Already we know that each element should be have equal dimensions. Already I am saying about in the last 15 minutes, each element is equal to equal dimensions, length, width, height, anything, equal dimensions. At the time, the model body is divided into an equivalent system, okay, of many smaller bodies. Okay, so any type of complex structure is divided into equivalent system by using many smaller bodies or units. That is also called as finite element method, finite elements. So in these finite elements, it is interconnected in at points, okay, common two or more. That means the point is also called as, in the finite element method, nodal point. Okay, the nodal point. So model body is divided into an equivalent system. ఏదైనా ఒక కాంప్లెక్స్ స్ట్రక్చర్ కనుక తీసుకుంటే దానిలో నెంబర్ ఆఫ్ ఎలిమెంట్స్ ఉంటాయి, నెంబర్ ఆఫ్ బ్రిక్స్ ఉంటాయి. సో అప్పుడు మనం ఏం చేస్తాం అంటే ఆ బ్రిక్స్ ని డివైడ్ చేసుకుంటాం స్మాలర్ గా. కాంప్లెక్స్ టఫ్ గా ఉన్న దాన్ని ఈజీగా డివైడ్ చేసుకొని ఒక్కొక్క ఎలిమెంట్ ని, ఓకే, ఒక్కొక్క ఎలిమెంట్ ని ఇండివిజువల్ గా ఫైండ్ అవుట్ చేసుకుంటూ వస్తాం. ఈ డివైడ్ చేసే ప్రాసెస్ ని ఏమంటారంటే డిస్క్రిటైజేషన్ ప్రాసెస్ అంటారు. ఓకే, నెక్స్ట్ వన్, This is the example of discretization process. For example, we have a object. That means we have a object. Object means only one element. So this is the whole body, for example. But in this particular body, it will be including into three elements. Listen carefully once again. This is the object. That means this is the body only. Okay. In that particular body, it will be including into three elements. How to find out? So, with help of this body, we are dividing into three elements. But three elements are equal dimensions. ఓకే, ఇది ఒక బాడీ అయితే నాన్న, ఈ బాడీలో త్రీ ఎలిమెంట్స్ ఉంటాయి. త్రీ ఎలిమెంట్స్ గా మనం డివైడ్ చేసుకున్నాం. హోల్ బాడీని త్రీ ఎలిమెంట్స్ గా డివైడ్ చేసుకున్నాం. ఫర్ ఎగ్జాంపుల్ 60 అనుకోండి, హోల్ బాడీ డైమెన్షన్ 60 అనుకోండి. ఫర్ ఎగ్జాంపుల్ 60 డివైడెడ్ బై 3, సో 20 20. ఈచ్ డైమెన్షన్ వాల్యూ ఈజ్ ఈక్వల్ టు 20 20 20. సో ఈక్వలెంట్ డైమెన్షన్స్ ఆఫ్ ఆల్ ఎలిమెంట్స్. సో దిస్ ఈస్ ద ఆబ్జెక్ట్. వన్స్ అగైన్, ఇన్ దిస్ పర్టికులర్ ఆబ్జెక్ట్, this is the complex region, at the same time complex structure also. In this complex structure, we are dividing into smaller elements. That is also called as discretization process. That is also called as finite element methods. After that, we are find out three elements in the particular body. After that, we are find out three elements in the particular body. Okay, each element, how many nodal points? For example, I am taking only green color element. So in the green color element, there is a one triangle. So point number 1, point number 2, point number 3. Point is also called as, in the finite element method, node. Okay, so each triangle ki 3 points ఉంటాయి నాన్న. ఆ points నే finite element methods లో మనం ఏమన్నామంటే node అంటున్నాం. node, NODE, is also called as node. Point is also called as node. Each element, how many nodal points? 3 nodal points, but it will be interconnected into the whole body. So total nodal points, how many total nodal points? 1 2 3 4 5. So in that particular object, in that particular complex structure, okay, in that particular complex structure, in that particular complex body, it will be including into three elements. Okay, it will be including into three elements. Okay, it's clear. Next one, how many nodal points it will be included? 5 nodal points. It's clear. So this is the meaning of discretization. Okay, next one. So in this discretization process, we are find out this is the process. So x-axis and y-axis. So this is the exact temperature distribution. In this exact temperature distribution, we are divided into smaller elements. For example, once again, this is the complex structure. For example, the discretization process of finite element discretization is complex structure. In that particular complex structure, we are divided into, with help of discretization, with help of finite element, we are divided into smaller elements. So this is the whole element. For example, this is the whole body. The curve is whole body. But the whole body, to find out the some analysis, it's very difficult. At that time, I am choosing finite element method. I am choosing discretization process. We are dividing into the smaller elements. Okay, the first one, T1 to T2, that is the element number 1. T2 to T3, element number 2. T3 to T4, element number 3. T4 to T5, element number 5. These whole elements, it will be including into this particular body. Okay, for example, this is the body. The curve is a body. The body is also called as structure. In this particular structure, to find out the stress analysis, to find out the displacement analysis, to find out the strain analysis also, it's very difficult. At that time, we are choosing finite element method discretization. With help of finite element method discretization, this whole body is divided into smaller elements. Smaller element number 1 2 3 4. So the whole body, it will be including into 4 elements. Okay, it's clear. each element should be have two nodal points. That means there is the point number 1, this is the point number 2. So each element should be have two node points or 2 points. So total elements is equal to 4, total nodes is equal to 8. It's clear. So after that to find out the individual stress analysis, strain analysis, displacement analysis, and then finally to assemble the whole body, to find out the whole stiffness matrix, to find out the value of analysis. Okay, next one. So for example, we are choosing one dimensional in the particular finite element method. It will be including into various type of elements. Okay, it's clear. But in this particular element, what is the element number 1? Types of elements of finite element methods. One dimensional, that is line element. One dimensional means line element. It will be including into x-axis or y-axis or z-axis only. Okay, that means x-axis only, we are taking only 2 points. That means one dimensional. And then two dimensional, that is plane. Two dimensional means plane. X-axis at the same time also y-axis. Okay, and then third element, solid element. It will be including into x-axis, y-axis, and z-axis. Once again, what is the types of finite element method? There are 3 type of finite element methods: one dimensional, two dimensional, three dimensional. One dimensional, it only x or y, and two dimensional, that is a plane element, it will be including into x and y, and three dimensional, it will be included, it will be named as solid element. The solid element means x-axis and y-axis and z-axis also. So this is the total elements of finite elements method, and then example of finite element method. So this is the only x-axis I am taking. Only x-axis I am taking. Why? Because one dimensional. Sorry, some mistake. Okay. For example, this is the two dimensional. Example of finite element method, two dimensional. So x-axis it will be mentioned, y-axis also mentioned. Once again, example of finite element method, it will be including into x-axis, also y-axis. In the second unit, unit number 3, which will be including into the finite element methods is two dimensional. And then example of three dimensional is a solid body. It will be including into x-axis, y-axis, and z-axis also. Okay. So next one. So advantage of finite element methods. In these advantage of finite element methods, it will be including into some model bodies of complex shape. Main advantage of finite, what is the advantage of finite element methods? The first point, any type of complex structure or any type of complex shape or any type of complex body, we are find out easily with help of finite element method. That is the point number 1. Okay, what is the advantage of finite element method? Means sometimes it is very critical. It is very critical, at the same time very lengthy process without finite element methods. Okay, so it will be also some errors, but in these finite element methods, we are choosing any type of complex structure and any type of complex body. We are dividing into smaller elements and solve individually and finally assemble the whole body. Okay, that is the point number 1. And then second one, can handle the general loadings of any type of boundary conditions. Okay, model bodies are composite to composite and multi-phase materials. For example, number of materials it will be including into some composites. Composite means in the particular material it will be including into various type of materials. For example, copper, nickel, aluminum. For example, copper, it will be including into various type of composites. Okay, that means it will be including into various type of materials. Okay, that means composition. Okay, and modally, for example, with help of this type of finite element methods to find out the value very near approximate value. Okay, at the same time to find out the any type of complex structure within certain time limit. Okay, at the same time to find out the any type of complex structure. And then disadvantage of finite element methods. The first disadvantage is time consuming process. Disadvantage of finite element methods, that first disadvantage is time consuming process. Okay, that means For example, any type of complex structure, we are dividing into smaller element. Okay. And then in these particular smaller elements, to find out the stress value, strain value, displacement value, at the same time support reaction value, to find out individually. For example, I am taking one wall. In that particular wall, it will be including into 100 bricks. So each brick, to find out the value of stresses, strain, displacement, support reactions individually to find out. It's clear. So at that time, very time consuming process. Okay, next one. The FEM cannot be produced exact value. Already I'm saying about approximate value. Okay, the finite element method, to find out the any type of problem, not produce exact value. It's find out approximate value. That is the another disadvantage. And then, for example, in order to analyze the many number of smaller elements and nodes also, already I'm discussing whole body with the whole body, to find out it's very tough. By using finite element method, to find out the smaller elements, at that time consuming process also. Okay, so today's class, this is the today's class. Any doubts? Respond anyone?
No, sir.
No, sir.
ఓకే, డెఫినేషన్ అర్థమైందమ్మా? ఫైనైట్ ఎలిమెంట్ మెథడ్ ఎందుకు యూజ్ అవుతుందో అర్థమైందా?
Advain, sir.
ఓకే ఓకే, సీ యూ టుమారో.
Okay, sir. Bye, sir.
బై.
Okay, sir. Thank you, sir.
Bye.
Hello.